Hello! In this video, we'll discuss and demonstrate some popular ways to expose applications in Kubernetes, including ingresses and gateways. We'll look at open source projects, where you have low-level networking control, as well as simple turnkey cloud solutions. All the demonstration code is shared in the video description. Let's quickly diagram this out to understand what we're trying to achieve. So our first option for exposing workloads, and the first example that we'll walk through, is the Ingress controller from Nginx. Now there are actually two Ingress controllers from Nginx, one developed and maintained under the Kubernetes project, and the other developed and maintained by F5. We'll look at the former case, the Kubernetes project Ingress controller. As a similar but more cloud-native and turnkey approach, we'll be looking at the GCE Ingress controller. The new Kubernetes Gateway API will also be of interest for us, and we'll cover its fundamental differences as compared to ingresses. The Gateway API is an important development to keep your eyes on, as it's more future-compatible and forward-looking compared to ingresses. While most of the discussion will be cloud-agnostic, we're going to demonstrate these networking approaches with Google Cloud Platform and specifically the Google Kubernetes Engine service. In this video, we'll be looking specifically at point solutions for exposing workloads and not broader networking ecosystems and service meshes like Istio. To highlight differences across the networking approaches, we'll use a few example use cases. The implementation of each of these cases will be used as code YAML specifications. As our starting use case, let's investigate HTTP to HTTPS redirects. We'll look at real configurations, evaluate how the networking options perform, and tabulate anything noteworthy for each of the options. Next, we'll look at host-based routing, how the networking options are similar and different in this area. After looking at the basics of host-based routing, we'll expand the picture to include header-based, URI path-based, and cookie-based routing. On the topic of redirects, we'll see how host-based redirects are implemented and include our findings alongside the host-based routing. As our last use case category, we'll look at URI path and header rewrites. This rewriting means that a request is changed at the load balancer level before it is passed along to the backend. SSL certificate management for HTTPS is also going to differ across these approaches. In Nginx case, we'll have to use something like the open source Cert Manager project for a semi-DIY approach to creating and maintaining SSL certificates. With the GKE native ingresses, we'll typically want to use the turnkey Google Managed Certificates, which unfortunately has a similar name of Certificate Manager. For the Gateway API, we're back to semi-DIY certificate management with the open source Cert Manager project. While there are certainly more approaches for SSL certificate management, these outlined approaches are most seamless and intuitive for their respective networking approach. Also, we must note that the supported capabilities and recommended patterns for all of these options can change, and the Gateway API in particular is under heavy development. Therefore, you should check documentation for the latest compatibility matrices and best practices. Okay, so let's look at each one of these use case categories in turn. We'll look at example YAML resources, which, again, are shared in the description of this video. However, we'll also virtually demonstrate a few examples to clarify the use cases and configurations. As far as prerequisites, I have already executed the shared code README steps to set up a Kubernetes Engine cluster, and we'll assume you've done the same if you're following along. I've also followed the same instructions to install the open source Cert Manager project. I've configured Cert Manager to use Cloud DNS for Acme challenges and have configured config connector to enable the YAML-based provisioning of non-Kubernetes Google Cloud resources. So if you're following along in the GitHub repository documentation linked in the video description, I ran all the way up until this Nginx Ingress controller setup. Okay, so with all that now established, let's go ahead and walk through the HTTP to HTTPS redirect use case across all three Ingress and gateway options. First up is the Nginx Ingress controller. Let's actually apply the associated Nginx Ingress resource now and note a few things. First off, we're using a TLS certificate that was provisioned by Cert Manager, as we don't have a great way to interface with Google managed SSL certificates. To give you an idea of how I provision this certificate, note that in this Kubernetes cluster, I've installed Cert Manager with Helm. After adding the configuration to create CRDs, I was able to set up a Cloud DNS Cert Manager configuration. From that foundation, we can use the Cert Manager CRD resources to create certificates and have them provisioned with Cloud DNS ACME challenges. So, for example, this certificate here can be used in our Nginx Ingress. Back to the core HTTP to HTTPS redirect consideration, note that we're very cleanly defining redirects through annotations. We'll also need to provide some TLS configuration along with our services and routing rules. Note that provider-specific Ingress configuration often needs to be done with annotations, while core Ingress capabilities can be specified in the spec section. As far as the backend services, we're able to use cluster IPs. Okay, so let's check on the Ingress that we created. We'll take the IP address for the Ingress controller and plug it into our DNS. It's worth noting that the IP for the Nginx Ingresses will always be the same value that we just plugged into DNS. That is, the demonstrated Nginx Ingress controller setup uses an IP per Ingress controller rather than an IP per Ingress like the GCE Ingress controller case. This can either be good or bad depending upon your desired IP allocation strategy. In any case, it's something to keep in mind. Alrighty, so for the visual folks out there, let's actually see this Ingress in action. We'll manually specify HTTP here in order to see the redirect, and it looks like we'll need to give this just a couple more minutes to finish creating. While that finishes out, let's walk through the equivalent examples in the GCE Ingress and Gateway API cases. First, let's check out the GCE Ingress. Fundamentally, this is an Ingress like the Nginx case, so it will be a similar setup. As far as the certificates, we have a nice way to manage them with this GCE Ingress approach. Unlike the Nginx case, this Ingress class will be available by default on our Google Kubernetes Engine clusters. Also, unlike the Nginx case, we don't need to run any pods or allocate any resources. The Ingress legwork is handled on Google's distributed network rather than the cluster. Using that config connector setup that we talked about earlier, we're provisioning a static IP using a YAML configuration. We're then going to use annotations to specify the static IP name and specify a front-end configuration. We'll come back to the certificate here in just a moment, but first let's address this front-end config. With GCE Ingress, this additional resource type, along with types like backend configs, give us additional control and flexibility beyond the Ingress annotations. So, for example, what I have in this front-end configuration is the HTTP to HTTPS redirect. When we attach this front-end config to the Ingress, we'll get the desired redirect behavior. We have services and deployments set up pretty similarly to the Nginx case, but note that we need to use node port configurations for the services. This service type exposes the services in a way that Google's global load balancing, which actually implements our Ingress, can see. Recall that we could use cluster IPs in the Nginx Ingress because our Ingress legwork was handled locally on the cluster. Alright, so let's round this out by looking at the Gateway API resources. This Gateway API is a relatively new addition to the Kubernetes project, and the capabilities are somewhat limited but evolving quickly. Anyway, in this setup, we have a similar use of the config connector for our static IP provisioning. We're using the semi-DIY cert manager setup for certificates. This gateway is going to listen on 443 and 80 for HTTPS and HTTP traffic, respectively. In addition to the gateway specification, we need these HTTP routes. So when we move from Ingress to the Gateway API, we have a decoupling of functionality. The gateway to route relationship is not always one-to-one. Rather, we'll always have a higher resource count compared to Ingresses, but no more than double. While this may first appear like additional configuration work, this decoupling actually ends up giving us much cleaner resource specifications and significantly more flexibility without having to resort to complex implementation-specific Ingress annotations. It turns out that the original Ingress vision packed a bit too much into a single configuration. As far as the resources behind the backends, we'll use the familiar cluster IP services and backend deployments. As we walk through this configuration, you may notice that there's actually not a redirect defined anywhere. That's because this sort of protocol and port redirect is not yet supported by the Gateway API. To reflect this, I've deliberately named this file HTTP and HTTPS rather than HTTP to HTTPS. And while you can serve traffic for both protocols, you'll have to handle the protocol redirect in your backend services, and I consider this to be a pretty significant limitation. As the Gateway API continues to develop, I'm sure we'll see support for HTTP to HTTPS redirect use cases. Alright, so we've walked through all three options to compare and contrast. Let's remind ourselves of the use case with a quick browser demonstration. And I'm now realizing as we go through these resources together that we need to change the example.com placeholder domain. We'll update our Ingress with the new domain, and in just a minute or so, we'll have our HTTP to HTTPS redirect working smoothly. Great. Let's apply the Gateway API resources and visually remind ourselves of the redirect limitation. We just need to use our gateway IP in a DNS record, and specifically, we'll edit that A record from earlier. While the change propagates, I want to highlight that the Gateway API is not usable with the default Google Kubernetes Engine cluster. You actually have to specify that you want Gateway API capabilities when you are creating the cluster. So, in the GitHub repository README, I added capabilities for DNS integration, config connector, and finally the Gateway API. The last piece here just allows the cluster to talk to any service on GCP, which in our case is used for auxiliary networking services like Cloud DNS. Alright, so if we go to the HTTP endpoint, note that it stays on HTTP and our clients are not redirected to HTTPS. We can run HTTPS, but we can't redirect to it. Let's wrap this up by looking at the Cloud Console a little bit, and we'll see how these resources look different. So I'm going to go to our project, which is different from the DNS project, and note that we have our gateways implemented as Google Cloud Load Balancers. These load balancers take advantage of the performance and scale of Google Cloud's distributed global networking, in contrast with the Nginx approach. Another note on Cloud Console visibility is that gateways and HTTP routes do not show up yet on the Google Kubernetes Engine pages. Since there's nothing to demonstrate there, we'll move along. Presumably, support for that will be provided at a later date. Let's capture some notes from our discussion. So this is DIY Ingress in the sense that the controller and networking legwork are all on the cluster itself. We will also typically need to bring our own certs for this Nginx approach. With the GCE Ingress, we have some additional flexibility as provided by the front-end and back-end configs. Seamless certificate handling is provided by those Google Managed Certificate CRDs. The Gateway API performs poorly on this use case, since we can't get the redirect on the Ingress load balancer level. Alright, so let's now look at our host-based, header-based, path-based, and cookie-based routing. Going back to our terminal here, we'll choose GCE Ingress to be our demonstrated case. On the discussion though, we'll follow the same progression as earlier and go from Nginx Ingress to GCE Ingress to Gateway API. Let's see how some of these resources look from the perspective of routing. So, with the Nginx Ingress controller, we have the ability to split traffic based on cookies, but with some limitations. We use these Nginx Ingress annotations to control this behavior, as cookie-based routing is not core to the Kubernetes Ingress specification. For the cookie routing, the cookie has to be set to always. This is somewhat limiting, as you may have other cookie conditions. For example, perhaps you care if the example cookie is set to foo. That would not be supported with the annotations here. To cover both sides of the traffic split, we're defining two different ingresses. This honestly feels a little bit clunky and unintuitive. As you may be correctly inferring here, we're also only able to split traffic two ways. We can't do more complex routing like three-way splits based on cookie values. As before, the service and deployment configurations are pretty straightforward and standard. Now let's go to the GCE Ingress. This option is quite limited with respect to routing. In fact, we really only have advanced routing workarounds by using redirects and CloudArmor policies. CloudArmor is Google's distributed web application firewall and intelligence security layer. Generally speaking, the GCE's Ingress capabilities are based on Google Cloud's global load balancing capabilities. So limitations in those load balancers, perhaps for performance reasons, mean GCE Ingress limitations. You get unmatched performance and scale, but pay for that in terms of configurability. Anyway, how we get around cookie-based routing limitations is by applying a backend config here, which leverages a cookie-based redirect CloudArmor policy. In some ways, cookie criteria are a specific case of header criteria based on how cookies are sent in HTTP requests, so our configuration is a specific case of header analysis in a CloudArmor policy. We'll check if the foo cookie is set to bar, and if that's the case, we'll redirect to this cookie match.notomatic.io domain. If it doesn't match, then we send the request to a different domain. Again, this isn't really request routing at all, it's a clunky workaround. The need to bring in another service, CloudArmor, also adds some complexity and cost. That all said, using GCE Ingress resources tied to CloudArmor policies can be an interesting pattern for really advanced public endpoint security, like for DDoS protection. Now for the Gateway API. This approach covers some of the use cases. As before, we have a decoupling of the gateway and the HTTP routes. We provide the hostname and an explicit header match to get us closer to that cookie-based routing. While it looks like we're checking for the foo cookie to equal bar, we have a potential bug hiding in plain sight here. Specifically, if we have more than the single cookie in the request, a likely scenario, this exact match will fail even if the foo cookie is set to bar. The comma delimited cookies will mean a very different and much larger cookie header. There's experimental support for regular expressions in the Kubernetes open source Gateway API, but the lower configurability of Google Cloud load balancing makes it tough to know if or when that support will be available in GKE with the Gateway API. Let's go ahead and apply one of these policies to see this in action and illustrate what we're talking about with the cookie routing. We'll apply the resources and then set up the required DNS record. Again, we have our DNS in a separate project, so I'm going to switch to that real quick and then set up in a new domain for us to showcase the cookie-based routing. You can see we have multiple IPs now, one for each gateway. The cookie starts unmatched here, and we're hitting that unmatched backend. However, if I set that cookie and then reload the page, we're now matching on that. Let's keep moving along and go back to our code. We won't demonstrate header-based routing because it's very similar. Header-based networking is, in many ways, just a generalization of cookie-based networking. We can take a quick peek at the configurations, though. In the Nginx configuration, we have the same canary pattern as with the cookies. We can do complex matching like with regex expressions. When we have header matching, that'll dictate which backend to hit. As before, we need 2 Ingress resources, and then we'll back those ingresses with cluster IP services. Just like the cookie case, header-based routing with GCE Ingress requires a workaround using Cloud Armor policies. We could make very complicated Cloud Armor rules, but fundamentally we're redirecting and not routing, which means we're not really meeting the use case. For a Gateway API, header-based routing can be achieved in a rather straightforward way. In fact, I would argue that Gateway API configurations are consistently clean and modular compared to Ingress configurations. Decoupling things like IPs and listeners from routing logic is pretty slick. Recall that the GCE Ingress is worse in this area, but Nginx is the absolute worst of the bunch. Alright, so we've looked at about half of these cases so far. We've covered the HTTP to HTTPS redirects and then some of the routing behaviors. Let's wrap up with the URI path regex routing, and we'll demonstrate this one in the browser. So again, let's walk through each of the approaches to see how these look. The Nginx Ingress has a pretty clean implementation. We say use regex, and then in our path specifications, we provide regex expressions for the prefix. Let's apply this resource while we're here, and then we'll walk through the other case while that is loading. Since the Nginx Ingress controller always uses a single public IP, we can grab that even if it's not yet showing up as the IP for that newly created Ingress. We'll set up our DNS record. And we don't want to make the same mistake as last time, so let's change that example.com domain and then reapply the resource. Okay, so let's see how this setup compares to the GCE Ingress and the Gateway API. For the GCE Ingress, this use case is covered only in a very limited way. With anything more than exact or exact prefix matching, we'll again have to use the Cloud Armor workaround. The policy says, when the request path matches an alphabetical string, we're going to redirect to this domain. Otherwise, we'll redirect to this other domain. As usual, this routing workaround doesn't really give us what we're trying to get here. Now, if we just need to route based on exact paths or path prefixes and nothing more complicated like regex, that's pretty easily achieved in the Ingress specification. So, if you, for example, have really simple path prefixes like this and need to route based on them, that's totally okay. Now for the Gateway API. Like with the other routing use cases, the Gateway API struggles a bit here. The routes are backed by cloud load balancing, so we don't have regex capabilities, but can certainly do exact matches and prefixes. We should also note that the Cloud Armor workaround that we've seen a few times for the GCE Ingress is not yet possible with the Gateway API. Hopefully, the ability to attach CloudArmor policies to Gateway API resources is on the horizon. Okay, so let's demonstrate this use case here, and then we'll return to our graphic to capture our latest round of findings. So if we go to the 123 subfolder here, note that we get sent to regex1. However, if we go to an alphabetical subfolder, we hit a different backend. So with that Nginx Ingress that we applied earlier and are now testing, we're doing routing based on URI path. We have true regex matching here and don't have to use clunky workarounds like redirecting. All right, let's return to our diagram and capture some of our observations. So first off, let's note the poor IP allocation control for Nginx. Remember, we get one IP per Ingress controller here, using the standard controller configuration. We have better control over IP assignments with the GCE Ingress, but really we have the best control over IPs with the Gateway API. The Gateway API has that nice decoupling of routing logic and endpoint properties. On the routing, here with the Nginx, we only have two-way splits and have to use the somewhat constrained canary pattern in annotations. With the GCE Ingress route, we only have clunky workarounds using CloudArmor. We can only natively handle simple routing like with hosts and URI path prefixes. In the Gateway API, we have a better set of routing capabilities and more flexibility. However, we currently have no regex support. Now, this might be a good time to bring up the documentation for the Gateway API. Since they are rapidly evolving, you'll want to regularly check on the current Gateway API capabilities and limitations. So, if we scroll down to the routing and traffic management, we can, for example, note the host and path-based routing. We see here that we can only use prefix and exact matches. And with header-based routing, we can only specify an exact match. This limitation was highlighted earlier in our investigation of both cookie and header-based routing. You don't see regex here because that's not supported with the GKE implementation of the Gateway API and perhaps may never be. Alright, so let's keep moving along by looking at some rewrites. When we talk about rewrites, we mean modifying requests before sending them to backends. After the rewrites discussion, we'll finish up by capturing notes on the SSL certificate management. The Kubernetes Ingress resource has never had much of a focus on rewriting use cases, so only a few implementations cover this functionality, typically by using annotations. Following the usual progression, we'll look at the Nginx Ingress first. So, I personally think this is quite elegantly approached, given that the Kubernetes Ingress specification pretty much ignores this use case. As long as our use case is relatively simple, we can define the rewrite target in annotations. Further, we can use a useRegex annotation and then reflect that in our paths. So, in this case, we're going to take a second piece of the expression here and replace the URI path with it. So, this subfolder is going to get removed, and we'll demonstrate that in just a moment. Behind the Ingress resource, we have the normal backing services and deployments. On to our other networking options. The comparison's really simple. That's because we simply don't have rewrite functionality in the GCE Ingress or Gateway API. So, on to that demo. We can see the single IP concept for our Nginx Ingresses here, since the Ingresses are both running off the same Ingress controller. And before we wait too long, let's remember once again to change our domain here. If you clone or fork the GitHub repository linked in the description, a quick find and replace operation would serve you well to get your own domain in all these configurations. It's also possible to investigate these networking resources with just IPs, but we found the demonstration to be a bit more interesting with domains and SSL certificates involved. This is also a bit more representative of real production use cases. In any case, feel free to copy and paste things and play with the configurations yourself. Alright, so let's try our endpoint here. When we go to subfolder /foo as our URI path, note that the path only shows up as foo on the back end, so our rewrite is working as expected. Again, we simply don't have this capability in the GCE Ingress or the Gateway API. Okay, so let's highlight some of the capabilities that these have in common, just to finish up. First, remember that if you're simply routing by host or very simple path matching, then really any of these options are going to work nicely for you. For example, whether we look at Nginx Ingress or the GCE Ingress, the host-based routing looks the exact same. Path routing is pretty intuitive as well. Things look a little bit different in our gateways, but the same capabilities are there. We're just going to route based on host names and also use our prefixes if we need that matching in our HTTP routes. Let's explicitly capture some notes about SSL certificates. Firstly, we're using that open source Cert Manager project for both the Nginx and Gateway API cases. We helm install the project, and then we can use CRD for provisioning certificates. The certificates are automatically maintained. The approach with GCP managed certificates is unfortunately very similar in naming, but differs by being both less flexible and more turnkey. When we have certificates at the load balancer level, we can see them in the console. So, ultimately, you're probably left with the question of which networking option is best. Unfortunately, there's no clear winner, even though these are all popular options. Let's write down some basic guidance real quick. So first, on the dimension of redirect support, you know HTTP to HTTPS use cases encourage the use of Nginx Ingress or GCE Ingress. For advanced routing use cases, Nginx Ingress and Gateway API have a clear edge over GCE Ingress. CloudArmor can be used in connection with GCE Ingress only, so for advanced security use cases that need CloudArmor anyway, the GCE Ingress should almost certainly be used. We'll also add that the Gateway API, which is part of open source Kubernetes and not just GKE, is generally seen as the long-term future for all these use cases. Another important note is that Nginx Ingresses are ran on the cluster itself in a semi-DIY style. So if I look for pods in our cluster here, you'll note that only the Nginx Ingress and not GCE Ingress or Gateway API are represented. With Nginx, all the routing and load balancing is handled on the cluster itself, and that has big performance, operations, and control considerations. While there are also big downsides, the additional control and flexibility of the Nginx Ingress means that, if you're willing to modify the source code, you can accomplish nearly anything, no matter how obscure or absurd. Now, most folks won't actually fork and modify open source projects like that, so if the serverless GCE Ingress or Gateway API options fits your needs, then the ease of use may outweigh the customizability. Put another way, GCP's GCE Ingress and Gateway API inherit the limitations, but also the advantages of the cloud load balancing service. Let's lastly be explicit about IP allocation. The configurability here differs significantly across the options, with Nginx being the worst of the bunch and the Gateway API being the best. All the code that we reviewed and used today is provided in the description of this video. While all three of these reviewed networking options have some important limitations, those can change very quickly. When making selections for your specific project, you need to account for ongoing development and evolution. That all said, we've hopefully clarified some important differences between these three ways to expose your Kubernetes workloads. If this overview at least helped you to know what you don't know, then perhaps it was a success. We'll keep an eye on the comments for any questions, and thank you for watching.